Okay, this will be the second part of section 4.1, the how to find the extreme values. Now, in the first part, we learned about absolute maximums and absolute minimums, and local maximums and local minimums, and we found that if you have a continuous function in a closed interval, that there is an absolute maximum and there is an absolute minimum, and they either occur at the endpoints or at the critical points in the middle. Alright, now we will actually, in this lesson, we will learn how to find them. There are three steps. First of all, because they can occur either at the endpoints or the critical points, we need to find the critical points. So we find the critical points, and how do you do that? You differentiate the function and set it equal to 0 and solve for x, as well as find out if there are any places where there is undefined. Okay. Step 2 is, once we find the critical points, we take the critical points as well as the endpoints. Why do we take the endpoints? Because the absolute max and minimum can occur at the endpoints too. And to put them all together, we throw them at the function and actually evaluate the function at each of those points. What points? The critical points and the endpoints. Okay. And then once we have all those function values, we take the largest and the smallest. Simple. The largest is the absolute maximum, the smallest is the absolute minimum. So we take this one, take x squared. Okay, so alright, so let's go to the first part. Step 1 is to find the critical values of the function. So we take the derivative, and the derivative is 2x, right? Okay, now 2x is a polynomial, so it's defined everywhere. There is no denominator or anything crazy like that, so you don't have to worry about why it's undefined. So because it is defined everywhere, we simply set it equal to 0. Set it equal to 0 and solve for x. Set it equal to 0 and solve for x. What do we get? We get x equals 0. So that's a critical point, and there is only one critical point. And what's the critical point? The critical point is x equals 0. That is step 1. Step 2, what we do is we take that critical point as well as the endpoint. So what are the endpoints here? The endpoints here are -2 and 1. Okay, so -2 is one endpoint, 1 is the other endpoint, and we plug all those into x, right? And we evaluate the function x squared, right? Okay, so 0 squared is equal to 0. Okay, if you put in -2, you get -2 squared, which is equal to 4. You get 1, you get 1 squared, which is equal to 1. So once again, we plug in the critical point, the starting point, and the end point. Okay, 0 squared, plug it, put it here. Okay, 0 squared is 0, and if I put -2, then I get what? Negative -2 squared, 2 squared, which is equal to 4. And if I take the last one, which is 1, I plug it up here, I get what? 1 squared, which is equal to 1. Now we have three values here, 0, 4 and 1. Now, well, we have plugged in the critical points and the endpoints, so the absolute maximum and the absolute minimum should be here. So out of this, what's the largest? The largest is 4, so that has to be the absolute maximum. And it happens at -2, so we say that absolute maximum is 4, and it obtained at x equals -2. So what's the lowest? The lowest is 0. Okay, so 0, and it is achieved where? It's achieved at x equals 0. So the smallest is 0 and also obtained at x equals 0. So the absolute minimum is 0, achieved at x equals 0. Absolute maximum is 4, achieved at x equals -2. Okay. Now if you look at the graph of this, you can see that this is actually true. Alright, you can see that the minimum happens at 0, right, which is also 0, and the maximum is where? 1 and 2, and you can see that the maximum happens at 4. So the absolute maximum happens at an endpoint, absolute minimum happens at an interior point. Remember, they can only happen at the endpoints or the interior points. Alright, let's take another example. Okay, let's take 8x minus x to the 4. So go to step 1 right away. So to find the critical values of the function, so you need to find the critical values, 8x minus x to the 4. So you take the derivative. The derivative of 8x is 8 minus the derivative of x to the 4 is 4x cubed. Now once again, look at this. Look at the derivative. The derivative is a nice polynomial which is defined everywhere. No denominator. So you do not have to worry about being undefined. Okay. So how do you find the critical points? Then critical points, you only have to set this derivative equal to 0. So if you set it equal to 0, right, then what do you get? You get 8 minus 4x cubed minus 0. Alright, and if you take this onto the other side, you get 8 is equal to 4x cubed, and then if you divide by 4 you get x cube equals 2, and then if you solve for x you get the cube root, which is 2 to the 1/3. Now be very careful here. Now why am I telling you to be very careful? Now if you look at 2 to the power 1/3, it's a value which is greater than 1. It's a value which is greater than 1. However, look at the interval. The interval that we are concerned about is actually what? Oh, I should have put the interval here, right? Okay, -2 and 1. How did I drop that? I'm sorry. Okay, so in -2 and 1. So if you look at this interval, okay, this value which is greater than 1 definitely is not in the interval, and if it is not in the interval you do not consider that as a critical value, so you do not include that value. Now let's go back to the first example that we did. Now here the critical value was 0. Now 0 is included in the interval -2 and 1, right, because it is between -2 and 1. That is why we included 0. If it is not inside the interval, do not include it, okay, because we are only concerned about the interval. Okay, so now what we do is, alright, we put the values in. So for critical value there's nothing because we had one value, but that's outside the interval. Okay, so we don't put anything, we just put the endpoints. Okay, so what are the endpoints? -2, so -2 and 1. So put -2 and 1, and then once again we evaluate the function. Remember to evaluate the original function at this value. So how do you evaluate it? At -2, so you go up to here, you have 8 times -2 minus -2 to the 4. So 8 times -2 minus -2 to the 4 with -16, and then this is -2 to the 4 is 16. So -16, which is -32. Now you want to evaluate it at 1. Where do we go? We go up here, we put 8 times 1 minus 1 to the 4. So 8 times 1 minus 1 to the 4, which is equal to 8 minus 1, which is equal to 7. So we have three values, 2 values, 7 and -32. We do not have any critical values inside the interval, so we do not put that. Okay, so the absolute maximum will be what? 7 achieved at what? 1. Absolute minimum will be what? -32 achieved at -2. So you will notice that here both the absolute minimum and the absolute maximum happened at the endpoints. Okay, it happened at the endpoints. Alright, so sometimes that can happen, right? Instead of happening at an interior point, both can happen at the endpoints. Okay, alright, let's take a third example. Okay, so example third, we want to find the absolute maximum and the minimum of this x to the 2/3 in -8, 1. Okay, so step 1 is to find the critical values of the function. So take the derivative, and I take the derivative, I get this. Okay, I use the power rule, right? Okay, so what do I get? 2/3 comes up in front, x to the negative 1/3. Okay, 2/3 x to the -1/3. Now be a little careful. Now next to the -1/3, if you take it down, you get what? 1 over x to the 1/3. Now take a look at this. Now there is no point, okay, of setting this equal to 0, because this will never be 0, because the only way this can 0 is for x to go to infinity. Can you see that? This can never be equal to 0, because if you set it equal to 0, you get 1 equals 0 or something like that. Okay, 2 equals 0 or something like that, which is nonsense. Okay, alright, so it is not 0 anywhere really, but it is undefined at a certain point. And what's that? It is, if you put 0 here, you get 1 over 0. Can you see that? 1 over 0, the denominator. There is a denominator, but very careful. When there's a denominator, okay, wherever the denominator becomes 0, the derivative is undefined. So if you look at the denominator is 0 when x is equal to 0. Can you see that? The denominator is 0 when you plug x equals 0, the denominator is 0. So if we plug in x equals 0, the denominator is 0, which means f prime is undefined. That means x equals 0 is a critical point, and that's the only critical point. So we have x equals 0 as a critical point once again. Alright, okay, and now what we do, you go to step 2, we put the critical point that we have, which is x equals 0, where the derivative is undefined, right? And the first endpoint is the starting point in -8, and the ending point in -1 is 1. So when you plug these things here, you get, when you plug in 0, right, what do you get? You get 0 to the power 2/3, which is what, 0. And then if you plug in negative 8, you get what, negative 8 to the 2/3, which is what, negative 8 to the 1/3 is what, negative 2. Negative 2 to the 2 is what, 4. And then if you plug in 1, you get what, 1 to the 2/3 is equal to 1. Is everybody okay with that, right? So we get three values, 0, 4 and 1. What's the largest? Well, the largest is 4. And what's the smallest? The smallest is 0. Alright, so the absolute maximum is 4, occurs at negative 8, and the absolute minimum is 0, which occurs at the point 0, right, which is the interior point. Now it's kind of interesting. So we have written that, and now take a look at this graph. Now 0 was a kind of strange point, right? Why? Because that's a point where the derivative got undefined, a critical point, right? Now it's very clearly defined in this graph. If you look at this graph, can you see, well, you can clearly see that the absolute maximum is occurred at somewhere here, right? Because the curve is somewhere here, right? Okay, but I'm more interested in the minimum. Can you see the minimum absolute minimum happens at 0? And why do we say that the derivative is undefined here? Can you see that this point is a sharp point like a wedge? At a wedge, the derivative is undefined. Why? Because if you look at the slope here is like on this side, the right side slope, the right limit of the slope, the right derivative, or the right limit of the derivative is 1, and the left limit of the derivative on the other hand is negative 1. Can you see? So the right limit of the derivative is 1, left limit of the derivative is negative 1. So there is no derivative because the left and right limits do not match. It's a good example of the usage of left and right limits. Derivative is undefined, but still we have a minimum. We have an absolute minimum at 0. It's a very interesting problem. Alright, so that's it for this section. We'll see you in class.